Today we'll be looking at how to solve rational equations. A rational equation is an equation that has at least one rational expression, that is, a fraction with some kind of variable. There are two ways of solving rational equations, and we're going to look at the method that's a little bit easier. The first method is to rewrite the equation to have a single fraction on each side of the equation and do so with common denominators. When you can rewrite it with the same common denominator, you can then assume that the numerators are equal. That method is a little more complicated. I prefer the second method, which is to rewrite your equation so you no longer have rational expressions. We do this by looking at what fractions we currently have, and we determine a lowest common denominator that we can multiply by. And that will be the method we try doing. Regardless of which method you pick, when you find an answer, your solution or root must always be checked against the original restrictions of the rational expression. Let's take a look at an example. So in this example, we have multiple rational expressions. We have the 1 over 2x and also the 2 over x. The first thing I like to do is just make a note of any restrictions off to the side. In this case, x cannot be equal to 0. The other thing I like to do is just determine what is my lowest common denominator. So looking at any fractions I have a 2 and an 8, so my lowest common denominator is going to involve an 8. And I also have a single x, so my LCD is 8x. What I can do next is multiply both sides of the equation by 8x, and I should do it to both sides of the equation. I'm just going to wrap both sides of the equation in brackets and put in an 8x so I can make it kind of clear that I am multiplying everything by 8x. But what I would probably do is actually just rewrite it 8x times 1 over 2x minus 3 over 8. And that's equal to 8x times 1 minus 2 over x. I'm going to go ahead and multiply out on both sides using the distributive property. And we get 8x over 2x minus 24x over 8 equals 8x minus 16x over x. And you'll notice there's a lot I can do to reduce some of these. I'll do that kind of as a next step. So anything that divides out to 1 and just rewriting this to clean it up a little bit, we get 4 minus 3x equals 8x minus 16. Just going to clean up that x a little. So we can see this is a lot less complicated and a lot easier to solve. In this case, we didn't even end up with a quadratic or anything complicated, so all we're going to do is collect like terms. I'm probably just going to move the x terms to the right and my constants to the left, and we get 20 equals 11x, or x equals 20 over 11. At this point, that is our solution or root, and I must check this against the restriction. In this case, my only restriction is that x cannot be equal to 0. So this is okay as a solution. X is equal to 20 over 11. The reason I need to do this check is it is possible to simplify an equation and find an equivalent equation that does not have the same restrictions. In order to solve the original equation, I need to make sure I'm not dividing by 0, so I need to make sure in this case that x is not equal to 0. Otherwise, I have a solution for my simplified equation, but not for the original equation. All right, that's pretty much the steps. Let's try this again one more time. Going on to the next one. This is a good time to pause the video and try yourself, and then unpause when you're ready to continue. All right, for this one, I'm going to start off by factoring and just making this a little simpler where possible. So in the first denominator, I can factor out a 3 times x minus 3. And that's equal to 1 over x minus 3. I'm also seeing this is kind of a good one for finding a common denominator and rewriting. But let's start off with our restrictions. X cannot be equal to 3, otherwise I would be dividing by 0. That is my only restriction. And this might actually be a good case for method 1. I'm going to go back to method 1 for a moment. Method 1 is to rewrite each side of the equation as a single fraction with common denominators. And then compare the fraction, the numerators must be equal. I like this because I already have single fractions. And I'm really close to a common denominator. All I really need to do is take the right side and multiply it by 3. And I'm going to do that in the numerator and the denominator. That way I'm multiplying by 3 over 3, or 1. When I do this, my left side is going to stay the same, x over 3 times x minus 3. My right side, I'm writing an equivalent rational expression, is 3 over 3 times x minus 3. So we can see we have a common denominator, and we have a single fraction on each side. For these two expressions to be equal, if the denominators are equal, the numerators must be equal. This is how method 1 works. Method 1 tells us the numerators must be equal, so x must be equal to 3. Now that's a perfectly valid way of solving. You could also use method 2 and multiply by an LCD instead. You're welcome to try that on your own. This gets us a solution, but we actually need to check this root against the restriction, because remember our original restriction was that x cannot equal to 3, or we are dividing by 0. Dun, dun, dun. All right, when we have something like this, we must reject this solution. The way I would verbally kind of explain this, I would say this root is extraneous. And in finding a solution, we would say that there is no solution. Or we would say that the solution set is empty. All right, on to one more example, getting slightly more complicated. Okay, again, as a first step, we probably want to factor and identify any restrictions, and then we'll take it from there. This one gets a little spicier because we have the quadratic, so it's a really good one to try on your own. Feel free to pause and then come back when you're ready to continue. All right, let's start by just factoring the right side of this equation. So I'm going to rewrite x over x minus 3 minus 6 over x plus 1 equals 12 over, I need to factor my denominator. I need two numbers that multiply to -3, but add to -2. That'll be x minus 3 and x plus 1. All right, so this is a case where I'm probably just going to want to multiply by the LCD. If I wanted to use the first method of setting one fraction equal to one fraction, I would need to combine the two on the left into a single fraction. It's not bad, it's doable, you could do that, or we could use the other method of multiplying by the LCD. Let's start with method 2, multiplying by the LCD, and let's make a note of our restrictions on the side. X cannot be equal to 3, and x cannot be equal to -1. Those are the two cases where we will end up dividing by 0. All right, finding our LCD. Let's look at our denominators. We have an x minus 3, and we have an x plus 1, and it's pretty clear that's our LCD. So what I'm going to do is rewrite the left side of the equation to have that common denominator. And I'm going to move a little to the left so we have enough space. So the first rational expression already has an x minus 3, so I must multiply by x plus 1. So x times x plus 1 over x minus 3 times x plus 1 minus our second one already has an x plus 1, so I should multiply by x minus 3 over x minus 3 times x plus 1. And that's equal to, our right side already has the LCD. 12 over x minus 3 times x plus 1. All right, I think we're at a point where we want to combine the left side of the equation if we can. So I'm going to write this as a single fraction. I'll save the distributing and combining like terms for the next step, but I'll just write it as one fraction. All right, in doing this, all I really did was find a common denominator on the left. I haven't actually multiplied by that LCD that I identified yet. So we're actually at a point where either method 1 or method 2 could work. If you want to set your numerators equal to each other, you can do that. You'll notice if you multiply by the LCD, you kind of end up just doing the same thing. So let's multiply by the LCD on this one and we'll see how that turns out being the same thing. In this case, I'm going to multiply by x minus 3, x plus 1, and I do it on the left and I do it on the right, x minus 3, x plus 1. And the reason this really works out the same is look at what we can then divide out. We can divide out that thing we just multiplied with our denominator. And that kind of shows us, well, yes, we can set the numerators equal to each other. In this case, we're going to have x plus 1, minus 6, x minus 3 is equal to 12. All right, and doing whatever we can to simplify this, we have x squared plus x minus 6x plus 18, watch out for the signs when you multiply that out, equals 12. And again, I'm going to try and combine all like terms. In this case, I'm going to move everything to the left side of the equation to do that. X squared minus 5x, and we have plus 18 minus 12, which will be plus 6, equals 0. At this point, we have a quadratic, so we're going to pick whatever method we need to solve that quadratic. This one's a pretty easy one to factor, so we will factor. Two numbers that multiply to 6 but add to negative 5, x minus 2, x minus 3, equals 0. So our roots are x equals 2, or x equals 3. And we must check these both against our restrictions. So we have two potential solutions, but if we go back to our restrictions, x cannot be 3, x cannot be negative 1. So this one actually has to be rejected. This one is fine. So check against restrictions. And we can tell just by looking at the restrictions, if we put x equals 3 back into our original equation, we can see we'll be dividing by 0, and we can't do that. You can test the other one, substitute in a value of x equals 2, and we'll see that that works. We call that first one, that does not work, extraneous. But we do have one solution or root, which is that x equals 2. All right, that seems like a good point to cut it off. There are 4 more exercises on this page. You are provided with an answer, though you don't have the steps. Try those and see how they go. Good luck.